Perfect.
Do you see it? Yeah. Okay, great. So 1 second, I'll just pull up this data. Um, hmm. So, yeah, I'm trying to find the,
No problem. You take your time.
yeah. Should be in the report, final one. Simulations.
Below the graph.
Mm-hmm.
About it more. I
Yeah.
think it's in the final results.
Final was I know it's not in the final. I wish Ralph was here. He has it on top of his head. Okay.
For the simulated results or the actual?
For the simulated results for the last motor we tested in the flight, because he was doing simulation, but I don't think if he uploaded it in the disk. So I can do this. This over here. Okay, so for simulation, maximum velocity we got is just a little bit more than 1,000 feet per second. And initial acceleration is 11 g for us.
Okay. And you know the stability of your rocket?
Stability, yes, it's a 1.75.
Okay. Okay, perfect. And
Try to keep it above the minimum requirement, but not too high as well. Do not overstabilize it.
no, no problem. Just I know I need to know these values for
Oh,
the
it's actually 1.77 to be more correct.
1.77. Okay.
Yeah.
Okay, perfect. Well, we can go with the aerostructure subsystem. Just I need to know or see the parts, for example, the nose cone.
Yes,
Can you
so
tell me about the material?
yeah, let me show it to you. So you want to start with nose cone. Over here, over here's a nose cone.
Okay, perfect.
Yeah, if you could just, so it is 36.5 inch long.
Let's rotate so we don't have
Yeah.
Yeah, thank you.
So it's made out of fiberglass and it has aluminum teeth. We also have this coupler connected to it. It's also fiberglass. We use metal parts to connect them together, so we can disassemble if we need to, but we usually keep it together. And we keep GPS inside here, one of the GPS.
Okay, only inside is the GPS?
Not only inside of this, but there is, yeah, over here, do you see this disc? So there is metal disc which has an insert inside, and there's
Okay.
plastic parts that holds GPS. Do you see? You have light.
Sorry, I can hear you in some moments.
Sorry, maybe this will be better.
Yeah,
Over
perfect.
here, this metal part holds plastic GPS holder.
Mhm.
So metal part needed for shock cord. You can see a ring over there that keeps shock cord connected to nose cone. And the plastic part holds GPS inside. So it's far enough from metal parts and it works through the fiberglass cover.
Okay. For that eyeball, do you use Loctite?
Hmm?
For the eyeball, you use Loctite to keep the eyeball in the position?
No, it's screwed inside. It's screwed in the metal part and connected with a bolt from behind.
Okay. Okay.
We could take it apart if you want.
No, it's okay for me.
He says it's fine.
Walter,
Yeah.
inside the nose cone is a metal ring, aluminum ring, and it's bolted right here, it's screwed on. So it's all mechanical, and that aluminum plate is where the recovery hooks up to. And it's a forged eye bolt.
Okay. Perfect. The eyeball. The question is, do you use? I don't remember the name. Loctite.
Um,
Glue. The glue.
He's
Keep the. Let me show you the.
What does he mean?
No, it's for the threading. It's for the. Let me put over it. So
Oh,
it's on screen.
okay.
We use red Loctite.
Yeah, that one. Sorry, my English is not the best one, but yeah,
Blue is permanent, and red is you can actually take it apart if you need to. So we use the red Loctite, and we use a lock washer on the backside. Actually, no, I'm sorry, it's not a lock washer, it's an aircraft nut, a nylock nut.
yeah. Okay, perfect. Thank you.
So there's no epoxy anchor points to anything. Everything is mechanical.
Sorry, I can hear you so much. Yeah.
All of the recovery is done mechanically. There's no epoxy joints or no epoxy attachments or anything. It's all mechanical so that forces get transferred all the way through to the airframe.
Okay. Okay, perfect. Thank you for the information. I take note.
It's no.
Okay.
You will ask.
Next one, for the body tubes, is what material do you use to make fiberglass?
Everything uses fiberglass for body tubes, so you can see them here. This further one is a body tube where we keep avionics bay and payload. We can show you them later because they're not inside right now. They totally can be removed without any problems and then put back. And this one here is a booster tube. It uses carbon fiber. I'm sorry, it uses fiberglass, and it uses carbon fiber as a fins.
Okay.
So we have fins made of carbon fiber with 3 layers of carbon fiber coating connected with epoxy.
Okay. What is the thickness of the fins?
Thickness of the fins is 3/8.
3/8. Okay. Your max velocity of your fin flutter is
It's like 12,000 feet per second, if I'm not wrong. Like way over what we would have.
okay, perfect. Okay. Thanks.
It's also they are asymmetric, so it even more decreases any opportunity of fin flutter.
Okay.
Walter, the idea is to do that. We know the fins are strong enough with the carbon fiber 3/8, but they did the laminations and they did it in ascending order so that at the root cord, there's 3 layers on each side. And as the fin goes up, there's less and less layers so that the fins actually get skinnier as they go up. So there's no
Okay.
harmonics that can flutter because it'll dampen out at different frequencies because of different thicknesses. So that's the reason they put the carbon fiber layups on there, is to eliminate the possibility of fin flutter with asymmetrical fins.
Okay, perfect. Sounds good. Thank you for the information. Can I look at the carbon fiber in the fins?
Over here.
Okay.
So the black part
Okay.
is
this nice.
carbon fiber. It also goes a little bit behind this gray paint, but
Okay.
that's mostly where it is. So we don't
Yeah.
use it anywhere further. So we have good RF transparency everywhere.
Okay, perfect. You already have the rocket markings, for example.
No,
In
we don't have
number-
markings yet, honestly. We will have tests flight tomorrow again. And
Okay.
then we will put marks after we sure that it will not get damaged.
Okay, perfect. Just be sure that the markings are in the competition.
They are. So we know about requirements from Spaceport to have marks on each body tube that, and also to have frequency on it, but we still have to paint the rocket after
Okay.
launch tomorrow, and then it will be put on it.
Okay, perfect.
We are aware about requirements.
Okay, thank you.
Mhm.
The couplers are for what material? Fiberglass.
Fiberglass as well. It's 1.5 caliber each side.
Okay, perfect. Thank you. And the thickness of the walls of the couplers.
I think it's, let me just measure it right in front of you again. Make sure. So thickness of every part is 0.1 inch.
Okay. 2.81. Perfect. Thank you.
It's same for body tube, same for couplers. 0.1.
Okay. And who is attached in the rocket? By screws or chemical like epoxy?
No, only screws, no epoxy.
Okay, perfect. Thank you. We can pass with the recovery. Can you tell me about the shot course, material, legs?
Yes. Material. Yeah. So we use Kevlar shock cords of different thickness and lengths. I could pull up the lengths.
Yeah, the Kevlar shot core is tubular.
Hmm?
It's a tubular Kevlar shot core.
See, it's
It's
it's not tubular. It's flat.
okay.
Sorry, don't get trying to. Do you need their lengths as well?
Yeah.
Yeah, I'm trying to pull it up right now to give you correct numbers. Mm. Have it somewhere saved because oh, maybe Sergio. Sergio, are you there?
Yes.
Do you have lengths of shock cords with you right now?
No, I put it with the avionics stuff.
I have it right here. So we do
Yeah.
have one 32-foot long shock cord, and it'll have a 8-foot loop at the end, and it's able to hold up to 5,300 pounds. And the other one is 24 feet in length and a 7-foot loop at the end, and it can handle 1,200 pounds. And let me turn my camera on quick to show you. Is it?
You have blur.
Right here.
Okay. Thank you. Thanks. Okay, for the next one is the main parachute. Just to know the size, color, is commercial or
So
you
it's
make-
commercial 84-inch white elliptical parachute, white and red color.
Okay, the descent rate of the main
What?
descent rate, the descent velocity.
Descent velocity when main is open, it's about 22 feet per second at the low altitude. So maybe in Spaceport will be about 24 feet per second.
Okay.
Because of lower density.
Okay. Thank you. For the drop parachute, the chute size, color is commercial.
Yeah, all of them for commercial. I think it's 36-inch, Sergio, if I'm correct. Yeah. And
Yeah, 36.
what
Okay.
color is
36 and
It's yeah, right there, yellow and red.
Yeah.
Mhm.
Okay. Perfect. Thank you. The next one, chirpings.
Um,
You do use it? How much?
yeah. We use 3 sharp pins, one of them between a booster stage and body tube because of volume we have in between those stages.
and we have two shear pins between nose cone and body tube. All of them nylon. 440 nylon ones. Do you remember how strong they are?
Show them the ground test.
Yeah, we have ground test if you want to take a look somewhere.
Yeah, if you have the video, is
Yeah, we have video. Just give me 1 second to pull it up. Or you can ask another question when I'm doing it, so we don't lose time.
okay. Well, the type of deployment is what power is CO2.
CO2. CO2, we have two CO2 charges between booster stage and body tube. And we have one CO2 charge between nose cone and body tube. All CO2 charges are 38 grams.
Okay, perfect.
I can share you videos to show how it looks. So over here are ground test videos. So it's with a shear pin, I believe.
Yes.
So I think this one is where we realize it. Yeah, over here you can see when we tried to use two shear pins, and it was not enough, like it was too much strength. So we had to remove one.
Okay.
Yeah, and then rocket worked well 2 times when we flew it.
Yeah. In all your flight tests, do you use Sharpins?
Yeah. It's the same in every flight test. We use the same
Okay,
things.
perfect. The next question is about the recovery protection for the chute on shot cord. Do you use someone or
So we
the
have
material?
few aluminum parts that serve to protect chute from going too deep in the rocket, but there is CO2, so CO2 doesn't damage chutes.
Yeah. Perfect. About the recovery hardware, quick links, hard points. You only I need to know the material and the size. I already see the eyeball in the nose cone, but
So we use this, it's steel, a stainless steel for all of them. It's 2 times more than we need of strength. And we use it for both main chute and drop chute.
okay,
I'm not sure about size, but it's big enough to fit eyeballs.
okay, it's okay. For bang holes,
Hmm?
sorry, for bang holes, for your avionics.
Avionics, Osiris, do you have it with you?
Yeah. Did you want to see the slider now or the? So this will be our full sled for the avionics right here. We got the HCX right here on the right. Oh, yeah, the right side. And on the left is the Easy Mega. This is linked and all the wires here are tinted and then cut short that they don't access the terminal. So they're more precise based off the guidelines. And then we do have two toggle switches right here. Each one representing the bottom one is for the easy light path as well. In back, we do have the batteries. So the HDX just take 2.9 volts. And then the Easy Mega does take a LiPo, which is covered right here. And then all these batteries don't have any vibration problems during flight at all either. And then all flight computers are CO2 charges on the bulkheads of the av bay, which I'll show you right here. Now this is where the CO2 will go. This is our cutter for the payload, and then this is the terminal
Sorry.
block.
I think your video stopped.
The
Try to
CD4
reload it.
units will be connected are in. Oh, did it stop?
Yeah, when you were showing CO2 and everything, we didn't see it.
Oh, okay. Let me. If it's is it good now? If I could restart.
Yeah, it's good now.
Okay. So I'll go back to. So I just show you the JTS connectors, the female ports that were on the sleds, but this is where I have the male JTS connectors, and they're located inside. I get a better view. They come through the bulkhead, and then they are linked right away using clips to the terminal blocks. The only thing that will be screwed down during the flight day will be the CDD4 units. You see here, this is the bottom part where the booster section. This is the 32 grams of CO2 will be plugged in. And then this is just one. And then that is our arming. For the cutter, it will just be one cable right there, that ignition cable that will be plugged into the HCX. So only that computer will be plugged into the cutter. But all CD4 units will be plugged into both flight computers. So for redundancy. Watch, I think you're muted right now.
Sorry, but thank you for the information. It's look good for me. Think that's very impressive. Okay.
And then we also do use an eye bolt and a threaded rod as well to hold the ab bay together to keep it fastened. And it's all just mechanical. And then we have pins here at the end to just make sure the eyeball doesn't move. So we're not using any.
Okay. Perfect. Okay. Let me see where.
Yeah, and then I'm not too sure if Vova mentioned, but this is the carbon fiber hatch that will be going on the main body tube of the system.
Yeah,
and then
over
this is
here.
the
So we have this cut over here. So when avionics bay is inside, we have easy access to it using this hatch.
Okay.
It's also
and then
juiced.
How many times your team take it to active the rocket?
Again?
How many times your team need to activate the rocket in the launch pad? You know it, for example, 2 minutes.
Like Osiris, how much is it? After we're ready, it's basically just to turn on the
yeah, so I would say at most it'll probably just take me 2 minutes or less. It's just
Okay.
once it's vertical on the flight on the launch pad, I would just have to be really close to it just to arm both of the flight computers and make sure I hear the correct beep sequences, for I can know that both flight computers are in the correct orientation and that all pyros have the correct polarity.
Okay.
Mhm.
Perfect. And now about the payload. Can you tell me something about the payload?
So we use 3-unit payload. You can see it over there. It's a steel frame made for weight. It has its own recovery system. And it has some plastic parts that hold GPS in it. And we have a camera connected. Maybe you can show it. There is lens on top of it.
Yeah.
That's
I don't think the
over
cameras are
here. You
plugged
can
in
see a
yet.
lens.
Yeah.
So we have this video recording on the payload. Yeah.
Okay. Perfect. The
It's about 9 pounds.
the payload is deployed or is attached in the
It's
rocket.
deployable. Yeah.
Okay.
We have video of its deploying if you want to see.
Yeah. If you have it.
Yeah, 1 second. I will just pull it up.
Yeah.
So over here. So this one, I think, yeah, it's a video how payload comes back on its own. It landed like 200 feet away from rocket.
Okay.
Quite close. Also, yeah, you can see that parachute for it is white and green.
Okay. Perfect. Thank you. And the saying of the rocket, you need to the payload need to have the marks of the team number and the frequency.
Yeah,
Just
we still have to do it as well for this part. As I said, we didn't paint things yet.
Okay, perfect.
But it will have it on the body, the side.
Okay.
By the way, you can see how rocket looks when it's assembled here. So this is all together with everything inside. And over here is how we prepare it. Have bay inside, payload inside, booster stage over there. Yeah.
Okay.
And you can see over there is nose cone, which is open, so you can see GPS standing. Maybe have better picture somewhere.
Okay. how much time your team need to assemble all the rocket?
It took us usually from 30 minutes to an hour, but if we will make everything ready ahead, it can be like 30 minutes or less.
Okay, perfect. It's a good time. Okay, now about the motor retainer. What do you use to retain the motor? Is a commercial?
Yeah, it's Aeropack motor retainer. You can see over here. 1 second.
Okay, perfect.
So
You
Commercial,
don't use bow tail, no?
what?
Bow tail. Your rocket don't have bow tail.
it's aluminum both sides over here.
It's okay.
It's connected to the retainer, so it's screwed together with bolts.
It's
Sorry, I
glued
think-
twice.
Okay.
Yeah.
Yeah. Perfect. The rail bottoms, just know how much do you use? If 15.
Do you mean rail locks?
Yeah.
Launch locks over here. So we use 2 of them.
Okay.
One over here, another one over to the end. You can see the pricing.
Okay. Perfect. Thank you. About the motor, you already have the motor of.
Yeah, we have the motor. We will have another one in Spaceport. It's going to be
Okay.
like we launched this motor already once to test it. We like it, and we will have it. We already got it from the guy. We just wait for delivery next week for
Okay.
another one. But we already secured this motor.
Okay. Perfect. Well, your how is your checklist about your rocket? You already have it all the
Checklist?
yeah. Yeah, I
Yeah,
don't no, you tell me.
we have checklist and we have what's called sequence lists. It's like 2 different things. So we have checklist to know what we need to bring with us, and we have assembly list to see how like which steps we need to do during assembly to get it done correctly.
Okay. Perfect. For me, I don't have any more question. I already have the checklist from Erva to check all the rockets, but for me, you have a good project.
Oh, okay.
I don't know you have any question about the competition, the launch stage, the safety review?
Maybe I have few. So first of all, first few days of competition is going to be safety checks and registration, everything. Is it happening in Las Cruces or at Spaceport?
In Las Cruces, in the convention center.
Okay. So, and usually what time it is from and until?
Let me check. I don't have the information of this year, but maybe it's the same of the last year. Let me check the schedule.
Okay, maybe they have schedule already.
Yeah.
And then for the launches, how early they start?
And 9 o'clock.
9 o'clock is when rockets already can fly, or when people can start preparing.
No, the launcher. Let me show you the. Let me share the screen.
Yeah, I'm just trying to verify.
Yeah. So I can share the screen. You can get the informations.
1 second. Try now.
Perfect. Okay, you can see it?
Yeah.
Okay, this is about the last year, but maybe it's the same. For the checklist, it starts in 9 o'clock to 4 p.m.
Mm-hmm.
And to the second day to 9 a.m. to 5 p.m. And the launch days for the first day in the Wednesday it starts
Mm-hmm.
uh, at midnight, yeah, at noon, 12 p.m. and
Yep.
close the range at
Oh, I see.
4:30.
So first days they start at 12.
Yeah.
Okay. And
And
then they
then,
have 7 and 6 a.m. range open. I see.
yeah, yeah, I recommend you to make the flight safety review the first day in the
Okay.
competition.
Yeah, that's what we're planning to do, and we want to be ready with everything over there.
Yeah.
Okay. Is there anything that we should bring others and rockets, spare parts, and everything to Spaceport? Like, except the stuff they mentioned already. Maybe there is something recommended to have, or some other stuff that can be helpful.
First, food and water, a lot of water you need to bring with us. And this year, the competition brings to all the teams tents and tables. You need to have chairs. You can buy it in Walmart, or if you have it, you can go with that. The clothes. I already have the information, but is a hat, launcher, uh, clothes, shoes, and maybe uh, it, they have they reach 115 degrees in the launch days.
150?
Fi-
15?
15,
Okay.
15, sorry.
Yeah, it's just
Yeah. Used to get the information and where let me show you the the checklist. I share you these documents at the end of the meeting, but is the
Okay.
checklist that I have in the of your rocket. For your information of this one is there is a border check for not U.S. residents. For you, it's okay. No.
We don't need, everybody is in US, so we're
Yeah.
fine with.
Okay, perfect. Just keep the time travel for the Las Cruces to the
So we're
space.
going to stay in Las Cruces.
Okay.
We have place secured already, so we should be pretty close to convention center, but to Spaceport launch site, it's going to be about 1 hour to get there, I think.
Yeah, 1 hour. The range open at 7 a.m., but most of the teams go out
Earlier.
5 p.m. and make a line to enter the
Yeah.
vertical launch area.
Makes sense.
Well, but maybe it's all the information. I send you by email all my recommendation for the team for the competition in a few days. But if you have any other question, you can contact me.
I think that's fine. I think they have enough support documents so we can check about other requirements, but that's good, unless you have any other questions about rockets.
Okay, perfect. Well, for me, it's all. Congratulations for your rocket. It's a good project. I wanna see in the competition. And tell me about the results about your launch and everything. Do you need? Just contact me. I be there in the competition all the days.
Great. Thank you, Walter.
Okay. Well, it was nice to meet you and have a good day.
Have a good day. Bye.
Bye.